The South Texas coastline, once defined by the quiet rhythms of nature and the gentle crash of waves, is now home to a new era of exploration and ambition. Today, the air vibrates with the thunderous roar of rockets at SpaceX's Starbase, a place where the boundary between Earth and sky is constantly being challenged. The second orbital launch tower, known as Pad-2, stands as a monumental achievement and a pivotal step in the Starship program's evolution. This isn't just another launch site, it's a bold leap forward, bringing SpaceX closer to the high flight rate and rapid turnaround envisioned by Elon Musk and his team. With Pad-2 now active, Starbase transforms from a single-pad outpost into a true spaceport, capable of supporting a cadence of launches never before seen on this stretch of coast. Previously, with only one pad, any damage or setback could bring progress to a grinding halt, as was evident after the first explosive test flights that left the original pad in need of repairs. Now, Pad-2 offers crucial redundancy, allowing one pad to launch while the other undergoes maintenance or upgrades, ensuring that development and testing can continue without interruption. Recent tests, such as cryogenic proofing and fueling rehearsals, have demonstrated Pad-2's readiness to support the next generation of Starship launches. Each successful milestone, from structural checks to full-scale rehearsals, builds confidence that Pad-2 can reliably support the massive Super Heavy booster and its ambitious missions. The sight of dual towers rising above the Texas coast is more than just a feat of engineering. It's a powerful symbol of progress, resilience, and the relentless pursuit of making space accessible. SpaceX's dedicated teams work around the clock, overcoming harsh weather, technical setbacks, and logistical challenges, all in service of a vision that stretches far beyond our planet. As Pad-2 comes to life, the pace of Starship's journey quickens, bringing humanity one step closer to a future where space travel is routine and the stars are within reach. Pad-2 represents a bold step forward in launch pad design, blending cutting-edge engineering with lessons learned from the past. It's not just an updated version of what came before, it's a complete reimagining, tailored for the demands of the world's most powerful rockets. Unlike its predecessor, Pad-2 is purpose-built to handle the immense forces and heat generated by the Super Heavy booster, making it a true evolution rather than a simple replica. One of the most significant upgrades is the innovative fire trench beneath the pad. This deep, reinforced channel is designed to redirect the searing exhaust from 33 Raptor engines, channeling it safely away from the structure and surrounding equipment. By guiding the exhaust, the trench prevents the catastrophic concrete-shattering damage that plagued earlier launches, protecting both the pad and the rocket itself. Another breakthrough is the dual-bucket water deluge system. This complex network of pipes and tanks unleashes torrents of water to absorb the deafening acoustic energy produced at liftoff. As the engines ignite, thousands of gallons of water flood into the buckets, instantly turning to steam and forming a protective cushion that shields the pad from both heat and sound. This steam cloud not only muffles the thunderous roar but also helps prevent damage to sensitive equipment, making the system far more efficient at sound suppression than previous designs. The launch mount itself has been heavily reinforced, with new materials and structural upgrades that reflect the hard-earned lessons from past launches and failures. Every element of Pad-2 is designed for rapid recovery and reuse, supporting SpaceX's ambitious goal of launching, landing, and relaunching rockets in record time. This relentless focus on iteration, building, testing, and refining drives continuous improvement, ensuring each launch is safer and more efficient than the last. Pad-2 stands as a robust response to the unprecedented power and complexity of the Super Heavy booster, meeting challenges that no previous pad has faced. The combination of the fire trench and deluge system is essential for managing the extreme forces unleashed at every launch, keeping both crew and hardware safe. These innovations are not just technical marvels, they're the foundation for SpaceX's vision of daily Starship launches, making space more accessible than ever before. In every way, Pad-2 is a testament to resilience, adaptability, and the relentless pursuit of rapid turnaround, a launch pad built for the future of space exploration. With Pad-2's structure now fully complete, SpaceX engineers turn their attention to the next critical phase, testing the pad's core systems. This is where months of design and construction meet the reality of operational readiness. Every integrated system, from the smallest sensor to the largest mechanical arm, must be verified to work seamlessly together. Teams meticulously check connections, calibrate instruments, and simulate launch conditions to ensure flawless performance. The gas supply system, a backbone for both safety and control, undergoes a series of rigorous trials. High-pressure lines are pressurized and monitored for leaks, while emergency shutoff protocols are tested to guarantee rapid response in any scenario. Engineers in safety gear carefully inspect valves and monitor delivery systems, ensuring the infrastructure can reliably deliver the precise gases needed for launch operations, even under extreme conditions. Attention then shifts to the booster quick disconnect, or QD, and the massive launch tower arms, both essential for fueling and supporting the rocket. The QD arm, a vital link for transferring propellant and data, is extended and retracted repeatedly. Engineers test its ability to connect and disconnect quickly, ensuring it can perform reliably during the countdown and at liftoff. Meanwhile, the tower's chopstick arms, giant robotic appendages designed for stacking and catching the booster, are put through their paces, lifting and maneuvering heavy segments with precision. These tests resemble a mechanical ballet, with each component moving in perfect sequence. Timing and coordination are everything, as even a minor misstep could impact a future launch. In mission control, engineers monitor streams of data, watching for anomalies and fine-tuning systems. Any issues are quickly identified and resolved, long before a rocket ever arrives on the pad. Each successful trial is a milestone, marking progress and building confidence in Pad-2's capabilities. The team celebrates as green lights confirm that core functionalities are proven and ready. With these systems now tested and operational, Pad-2 stands ready, an active, high-tech gateway, prepared to welcome its first rocket and support the next era of launches. While Pad-2 progresses, the next-gen Starship hardware advances. Booster 18 and Ship 39, the first full stack of version 3, are in focus. Raptor 3 engines, redesigned for higher thrust and reliability, power the booster. The hot staging ring, refined from past flights, enhances performance. Ship 39 features new recovery systems for better splashdown success. Redesigned header tanks improve landing burn efficiency. Production of these vehicles shows SpaceX's rapid manufacturing pace. Each new vehicle incorporates lessons from previous flights. Version 3 hardware, with its powerful engines and improved systems, pushes Starship's performance. This evolution is key to SpaceX's ambitious goals. Version 3. Upgrades translate into significant performance gains. Raptor 3 engines increase payload capacity, crucial for deep space missions. Improved hot staging and engine performance boost flight rate and reusability. These enhancements lower launch costs, enabling more ambitious missions. NASA's Artemis program benefits from increased payload capacity. The vision of a Mars city relies on frequent Starship launches. Version 3 bridges Starship from test project to operational system. Higher thrust and improved systems unlock more frequent, heavier flights. This evolution is vital for building a human presence on the Moon and Mars. With Pad-2 ready and version 3 hardware assembled, the focus is on Flight 6. This inaugural launch from Pad-2 will test the new vehicle and pad systems. A successful launch doubles SpaceX's Starship capacity. Flight 6 aims to push version 3 through a full launch profile. Key objectives include testing recovery systems and booster landing simulations. The flight will test Raptor 3 engines and new pad design under real conditions. Success validates years of work and accelerates launch cadence. A launch is targeted in the coming months, pending ground tests and FAA approval. Flight 6 marks a new phase for Starship, advancing interplanetary travel. The launch will be a significant milestone for SpaceX's ambitious goals. While Starship development continues, SpaceX serves customers with Falcon 9. This dual focus highlights SpaceX's operational maturity. Falcon 9 supports the International Space Station, launching cargo and crew. Recent missions include a successful resupply to the ISS. These routine missions are crucial for the station's operation and research. Falcon 9's success funds Starship's development. Revenue from launches provides financial stability for future projects. This business model allows calculated risks with Starship. Falcon 9 is the engine powering SpaceX's future. The steady cadence of launches underscores SpaceX's capabilities. As Starship tests capture attention, Falcon 9's success provides credibility. SpaceX's foundational role in spaceflight supports its grand ambitions.